Alright, hello everyone, so it's Colorful Shirt here, and today we're going to be solving LeetCode 198. You can pause the video and read the question, but I'm going to quickly explain it. Essentially, we're a house robber, and we can we could rob houses, but with one constraint. They can't be adjacent to each other, because that would alert the police. So we want to know, what's the maximum amount of money we can collect without alerting the police? So in the first example here, we would rob house 1 and house 3 for a grand total of $4, because that's the maximum you can take without alerting the police. 3 and 2 is more, but they're adjacent. It would be a total of 5, but you would alert the police and that wouldn't be valid. And we're going to get into how to solve this one. This is a dynamic programming problem, and one thing with dynamic programming is we usually have to solve sub-problems to get to the main problem, and I'm going to explain what that means here. The sub-problem here is, what's the maximum amount that we can rob from each position, and then we're just going to take the maximum at the end. So we're going to figure out what's the maximum we can rob at position 0. So if we're just looking at index 0, what's the maximum amount we can rob? And we have this DP array because we want to know what's the maximum rob from each position, and each of these lines is a placeholder for how much we can rob at that position, just to make everything clear. So at position 0, the maximum we can rob, we only have one option. It's just the 1, so we're going to put a 1 here. At position 2, what's the maximum we can rob? That's essentially like if we're looking at an array that looks something like this. If we have a 1 and a 2, if we're looking at our eyes, it looks pretty clear. We'd take the 2, right? Because $2 is greater than 1. Now, when we get to index 2 with a value of 3, how do we figure that out? Well, we know we can't rob 2 adjacent houses. So what we can do is take the value of the current index, which would be 3, let me write that right here, plus the value that we robbed 2 houses down. And we do 2 houses because that's the nearest non-adjacent house. So it'll be 3 plus whatever we can rob at index 0. And as you can see, index 0 is already filled out, so that would be 3 plus 1. And that would be 4. And if that, and the other option is, actually I wrote a 3 there. It's 3 plus 1 equals 4. Or we can just rob the previous house. In that case, it would be just a 2. 4 is greater than 2, so we're going to take the 4. And same story here at the last index. We can either rob this house plus 2 houses back, or we can rob the previous house and skip the current house. So in this case, it would be 1 plus, and we look at 2 houses back, that would be a 2. So 1 plus 2 is 3. So that would be I can't draw today, so like 1 plus 2 is equal to 3. Or we can just rob 1 house back and skip the current house, and that would be a 4. So 3 or 4, what's greater? It's 4, obviously. So we'd grab the 4, and we'd return what's the maximum number in this DP array, and that would be 4, and that's our answer. And this is how we're going to solve it. So first, we need to create that array that essentially is our placeholder. So we're going to call it DP, just like in our example, equals an empty array times, and it's going to be the length of nums, because we want to know what we can rob at each position, so length of nums. And before we continue, we do have to have a base case. And the base case is, if we're given an array of length 0 or length 1, like something like this, we just want to return nums of 0, because we can't, there's no houses. I can't go back, I can't go forward. There's only one house to rob. So we're going to say if the length of nums is equal to 1, return nums of 0. Perfect. Next, we want to fill in our DP array. And as you remember here, we know that the first index is always going to be the first index, and the second index is going to be the max of the first and second index, because we either rob index 0 or index 1. So we're going to say DP of 0 is going to equal nums of 0, and then DP of 1 is going to equal nums of, well, no, it wouldn't equal that. It would equal max of nums of 0 and nums of 1. And that would essentially get us our 2 here. Next, we're going to have a for loop, and it's going to fill in the rest of the array based on that logic that we just outlined in the drawing. So for I in range And we're going to start off at 2 because we already filled in 0 and 1, so we're going to start off at 2. And we're going to go into the length of nums. Next, we want to fill in each position, so we're going to say dp of I equals, and if you want to pause the video and figure it out for yourself, you can, but I'm going to explain it really quickly again. So we're going to either rob, it's going to be the maximum between the current number, so nums of I, in this case that would be the 3 in this example, the 3 right here, plus dp of I minus 2, because that's the nearest adjacent house. Or we can just rob dp of I minus 1. And that's this, and let me just show you one more time. So that's like robbing the 3 plus the 1 for a grand total of 4, or we can just rob the 2. And we want to grab the maximum between those two. That's filling in our array, and next we want to return the max of dp. And this should give us our answer. Let's try it out really quickly. And there you go. That's how you solve a dynamic programming question. See, it wasn't even that bad. Drop a like, do all that good stuff. Peace.